Hey class, and welcome to a help video to get you started on lab number 1. So I want to walk you through a little bit of what we're going to do. Some of the things that you're going to need for this first lab is two different measuring devices. So I got a tape measure here and I got a ruler. You could also use something like some calipers or something like that as well, or a meter stick if you have one. You'll need a piece of paper, not too exciting. You'll need some sort of a ball, so preferably something small but not too light. I wouldn't recommend a ping pong ball, but something like a baseball or a tennis ball. A soccer ball or something larger would work okay as well, but I'd say a smaller, denser ball, a bouncy ball, something like that would probably be best for what we're doing in today's lab. But that's it. So first lab doesn't have a lot of materials. So for doing these labs, the first thing that you need to make sure that you're doing is you're getting prepared by working on the lab. So here we have lab number 1, as you can see. All right, I went through and acted like I answered the pre-lab questions. I'm not going to tell you the answer on all of those, but you should answer these pre-lab, so before lab, as the name implies. Some questions like this one here, it says to make a sketch of position, velocity, and acceleration versus time of different situations. So on these, you do those on a separate piece of paper or on an iPad or something, and then you'll insert those in. So just to show you, if I go to insert a picture, I actually took a picture and put it on my desktop earlier of just sort of a sketch of a few little graphs. Yours will hopefully look maybe a little bit nicer than this, but you can see I just acted as though I was doing velocity versus time for these four different situations, A, B, C, and D. You'll have 12 total graphs. These 4 for velocity, also 4 for position, and 4 for acceleration. And you just need general shapes, kind of like we see here. Maybe a little bit nicer. So then getting into the actual lab, you're going to, in part A, go through this procedure of measuring a piece of paper 5 times. Now this sounds dumb, right? I'm making you measure a piece of paper 5 times. Are you serious right now? But that's exactly right. I'm going to make you measure this 5 different times with each of 2 different measuring devices to try to figure out what the width of the piece of paper is. Okay, so this is a little bit tricky, all right? And really what I'm trying to show you is a little bit about the scientific process. I'm asking you, hey, what is the width of this piece of paper? And I'm guessing many of you look at it and like, oh, it's 8.5 inches. But are you sure? How do you know? The box might be said this is an 8.5 by 11 inch piece of paper, but how do you know the box is not just making stuff up? And is it exactly 8.5 inches? Is it 8.5000 inches, or is it really 8.49 or 8.48, or who knows, right? Well, let's do a scientific experiment. Let's measure it and try to figure out. So you're going to take this piece of paper and you're going to measure it. And if you notice in the instructions, I tell you to measure it to 4 sig figs, 4 decimal places if you can. So take it and just place it at a random location on the piece of paper, and then you're going to look at one edge of the piece of paper really closely. So if you notice, this location right here, we're going to use the metric side, all right? The location on the meter stick of the right side of my piece of paper, or left, depending on which way you look at it from, would have a tens place, well, a ones place of 0, right? It's less than a meter because we're well less than 1 meter away from the end. And then the tens place is also 0, so 0.0, and then I see the 5 centimeter mark, so 0.05, and then I count these little millimeter marks. So from what I can tell, I see 3 of them, so 0.053, and then I can estimate one more digit, and my last estimated digit, I'm estimating on a scale of 1 to 10, how far between those tiny little black lines it is. And so I'd estimate the last digit, it's barely past the third one, so I'd estimate a 1. So the location of this side, I put in my table as 0.0531 meters. Then I go over to the opposite side and do the same thing. So if I look over here, it looks like it's covering up just barely the 27 centimeter mark. So I'd do 0.27, and then the number of millimeters it's covering is 0. It's not covering any of them beyond the 27. So 0.270, and then estimating the last digit, it's a little bit further than the last one, I'd say a 3. So 0.2703 meters. So that's what I would place into my data table. So if I came down here in my data table, the left side of the piece of paper was 0.2703 meters, and the right side was 0.0, what was it, 531, I think is what we said. And then this here would be the difference between those two. So you subtract them to the overall width here, which I think is, let's see, 0.2, what does this come out to be? 0.21, what is it, 72, something like that? Is that right? Anyway, we'll act like that's right, but you can check my math if you want to. And then you do it 4 more times, and then you move on and do it again with another measuring device, such as the tape measure here. So you want to do it 2 different times, 5 trials each, to see how they compare. Once you have your different trials, you'll calculate the mean, the standard deviation, and the standard error. All of these can easily be measured or determined or calculated using Google spreadsheets. So I'd recommend using Google Sheets and or Excel for doing these different functions. If you need help with how to do that, just let me know and I'd be happy to help you out. So moving on then, part B, what you're going to be doing is you're going to be dropping a ball 10 times from a measured height and measuring the time and trying to calculate the acceleration due to gravity based on our kinematic equations. So for part B, I'd recommend trying to find somewhere where you have as much height as possible. Just standing and dropping it with the ball above your head, it's going to be such a short distance, such a short time that any small error in your measurement is going to make your G values very, very large. So I'd recommend, I'm going to go, I would go out onto my back deck, which is above the ground, and because of the way our house is built, it's probably something like a good 20 feet or so off the ground. I might drop it from there, or even inside the house if you have a second story, to just drop it from upstairs down to downstairs. If you don't have that kind of space or something, that's okay as well. You can just try to maybe stand on a table or a counter and drop it from there. But you need to measure the height, again, probably using your tape measure, and then measure the time. It'd be hard to do this completely by yourself. You probably could, listening to when it hits the ground, but I'd also encourage you to try to get some help from, maybe a friend or a family member if you have anybody around, but you can also do it by yourself. So again, you're going to do that 10 times, measuring the height, which should stay the same because you're dropping from the same height every time, and then measure the time it takes, and then use our kinematic equations to calculate the acceleration due to gravity. Again, you'll do mean, standard deviation, and standard error for each of these. Right here where it says resulting G, just so you know, you'll see this in multiple different labs, but what that is that's your mean plus or minus your standard error. So in any scientific experiment, what your results are not one number. You don't do an experiment to find gravity and you say, hey, we found gravity to be 10.1 meters per second squared. No, you don't know that it's exactly that value. Your values are going to be all over the place because the nature of doing science is there's always some amount of random error involved in any experiment, even the best. So a good science experiment does not report a single value, but instead reports a range, the average of your trials plus or minus your standard error for those trials. That range is what you're going to report as your results, because what you're saying is that I did an experiment, there was random error, so I never got the same exact value each time or 2 times in a row even. Sometimes you might randomly, but normally you get different values each time because there's random error and there's limitations to the accuracy of your equipment and your experimental setup. But what you do find is that after doing this 10 times, you're fairly confident that the true value, based on your experiment, if your experiment was designed well and if there wasn't human or systematic error, the true value falls within that range of your mean plus or minus your standard error. So all experiments, I want you reporting a mean plus or minus a standard error. That's the best way to do good and accurate science. Okay, so you're going to be reporting your resulting G right here. Now the next part of the experiment is to look at some of those kinematic equations that we have and to try to determine them from actual experimental values. So for this one, again, you're going to be taking a ball and dropping it from some height. In this case, you don't actually have to measure the height. All you need to do is take a video of you dropping the ball straight down from some height, and then you need to import your video onto your computer. So there's this Tracker video analysis software. I want you to download it. All right, it's a free download. So follow the link here and download it. And the Tracker video analysis software, I'll go ahead and open it up for you all here. Went past it. Here we go. Should look something like this. Sorry about the delay. Probably I should have opened this ahead of time. So here this is. I went ahead and made my video already. So I'm going to come up here. I'm going to go File, Import a Video. And I have a little how-to tutorial video of how to work Tracker as well. But I'm going to import my video. Here I have my video where I'm going to be dropping my tennis ball. Now my video came in sideways, so I need to switch it. Under Video, there's this filter, New, Rotate. It's weird that they call it a filter, but I'm going to rotate it so that it's vertical. And so now you can see I just made a simple video dropping the tennis ball. If you want higher resolution, you could also do a slow-mo video, but I just did a normal speed video. Now on this, I need to then track my tennis ball as it falls, but the first thing I need to do before tracking it is I need to set up a calibration. So this is the little symbol for the calibration. I'm going to do create a new calibration stick. Now I need to tell it what a certain distance is, because everything in this software is based on the number of pixels. So I need to tell it, and this is why I have this little ruler that I'm holding the same distance away from the camera that the ball is. I'm going to tell it that this ruler, and I measured this earlier, is pretty much exactly 31 centimeters long. All right, so I'm going to come over here. Maybe I'll zoom in even more to try to be more accurate. Okay, zoom really in there. And so I'm going to hold shift now that I have my calibration stick, click on the very top, and then holding shift, I'm going to go down and click on the very bottom. So right now it just default says, oh, I wonder, maybe that's 87 meters. It's not, I'm not that tall. Instead, it's 0.31 meters. So now I set up my calibration. I'm going to zoom back out and go up to my tennis ball. And now I want to track the tennis ball. So I'm going to do create a point mass. And now I want to track the ball. I'm going to try to click on the center of the ball. As it starts to move, it's going to get blurry. So I'm going to do my best estimation of where the center of the ball is. But I hold shift, and then if I click on the center of the ball, you'll watch the video automatically moves to the second frame of the video. So I'm going to just keep clicking on the center of the ball until I actually release it. There's a small delay here. So I just keep clicking on the center of the ball. Apparently I moved it up just a little bit before dropping it. Okay, now it's starting to move. And so now I just keep tracking, clicking on the very center of the ball in each frame. I'm holding shift this whole time and clicking on the center of the ball the best that I can. Just keep going. There we go. Starting to get a little blurry, so I'm doing the best I can. So you can see there's it tracking it frame by frame. I scroll down, hold shift down again, click on the middle. Again, it's getting hard to tell where exactly the ball is as it's sort of a blur, but click on it each frame and then it's almost to the ground, so I'm going to stop there. All right, so that's my tracking. Over here, if I click on the table, I only care about the Y direction, so I'm going to get rid of the X. So I have Y, I want the velocity in the Y and maybe the acceleration in the Y direction as well. All right. So if I go ahead and close this, now I have some data over here in my data table. Notice this very last value is 0. That's thrown off by probably it hit the ground or I messed up somehow. So I'm just going to highlight the data points above that, going up until it looks like the ball wasn't really moving. Looks like I didn't drop it till right about here. So I'm going to just highlight these points. I'm going to copy them from here. So I just hit Control C. And then I'm going to put them in a Google spreadsheet over here. And there's my data. So now I can use this data here to do the different types of analysis that I might want to do. You can change the format if you don't like it in scientific notation. You can even add decimal places if you want to. But anyway, so now you can go ahead and do the different analysis that you're asked to go through in the lab. And the lab sort of walks you through it. You might want to highlight, you can insert a graph based on this, right? You can create some sort of a chart from it if you want to, or an XY scatter plot. Once you have the chart or the scatter plot that you desire, you can then do the fits to it as well. So I asked you to do different types of inserting of linear fits and so on. If there's any of these things you don't know how to do, you're welcome to ask me or just search, just Google, hey, how do I do a quadratic fit in Google Sheets and that kind of thing. So from there, you should be able to, again, go through and fill out these data tables following the analysis procedures here. So that's a basic how-to on this first lab. If you have questions, again, let me know. We can always set up a Zoom meeting together, or you can just email me and I'll